Well, this is the first problem regarding Banach matchbox problem, and second part is there. Second part is in this page number 75, and second part is there in your exercise. In exercise, probably this is the question number 15. আমরা এই দুটো কোশ্চেনই ডিসকাস করব. So let us first go to the uh, first part, that is this one, Banach matchbox problem. What does it say? It says that a mathematician always carries two matchboxes. বাংলা যেটাকে বলে দেশলাইয়ের বাক্স. Always carries two matchboxes, each containing n matches or match sticks. Whenever he needs, maybe for smoking or something else, whenever he needs, he chooses a box at random and draws a match from it. Find the probability that when the first box is found to be empty for the first time, the second box will contain exactly I number of matches. When the first box is found to be empty for the first time, the second box will contain exactly I number of matches. That means we can say we have two match boxes, and the mathematician draws one matchbox randomly. So we can consider the drawing of first matchbox as success and drawing the second matchbox as failure. Therefore, success and failure, these are actually technical terminology. We define the drawing of first matchbox as success and the drawing of second matchbox as failure. Now let us try to understand this problem in a different fashion. Suppose we have 10 matches in a stick. Sorry. Okay. And 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. And suppose this row designates the first matchbox, and let us insert one more row. Suppose this row designates the drawing of second matchbox. Suppose if the first drawing is considered as success, let us designate it by small s. And suppose it is filled by 10 match boxes, so we should have 10 number of success. And next, suppose this is filled by failure, so this is filled by F. Okay. Now the mathematician randomly draws any one match boxes. So we can say that in each and every trial, the probability of success and probability of failure are equal. Therefore, success and failure are equally likely. And as because the drawing is random, Therefore, we can say that probability of success is equal to half and probability of failure is equal to half. So we generally define P is equal to the probability of success, and therefore in this case probability of success is equal to half, and of course Q, that is actually the probability of failure, that is also is equal to half. Now what we need to do, we in the question, as per the question, we have to say that over here n matches are there in this box. So over here I have taken 10 matches, therefore n is equal to 10 over here. 10 matches in each box, 10 matchsticks in each box. So over here n is equal to 10. Fine. Now what does it say? It says that whenever he needs, he chooses a box at random and draws a match from it. Find the probability that when the first box is found to be empty for the first time, the second box will contain exactly I matches. Okay. Okay, fine. Now let us try to draw some matches or match sticks. Suppose for the first time I am trying to insert one more table over here, and suppose the table contains 20, not 20, I maximum need about 15 or 16. So, fine. Now suppose these are the number of trials. I am considering 15 trials over here. Now suppose for the first time over here, for the first time the the mathematician draws the first match box. Okay, then he would draw a stick from that match box, and I am writing success as because he has drawn the first matchbox and taken a stick, and then of course the first matchbox will have one stick used and remaining 9 sticks, that means n minus 1 number of sticks. Okay, and similarly suppose in the second trial the mathematician again draws the first stick, the first matchbox, and uses a stick out of it, so the number of sticks would be decreased. And then suppose he draws F. Fine. Then he draws suppose one more failure F. Okay, fine. And then suppose he draws the first box, that is success, and then again consecutively two success. That means this and these sticks are gone. Next, suppose he draws the second box, that means a failure should come. Then suppose he draws a success, and then once again he draws the first box, that means two sticks out from the first box are already used. Now suppose he draws a failure. Fine, one is gone. And then suppose successively he draws success, 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 then these three sticks are used. So now these three sticks are used. Still after observing that the first box is finished, still after using this last stick out of the first box, he does not throws the matchbox. He again keeps the matchbox in his pocket. And suppose maybe in the 15th trial or 16th trial, maybe one more trial, let me insert one more column over here. Column number 16, trial number 16. Suppose in 15th trial he draws a failure, that means he chooses the second box and uses a stick out of it. Okay, And then in the 16th trial, okay, he randomly chooses the box, and eventually suppose in the 16th trial he chooses this first box and finds, oh my god, the first box is empty. Okay, so the fact is about the trial number 16, not about trial number 14. Be very careful. These are two different cases. I am talking about trial number 16. Okay, and the question says that in such cases, whenever the mathematician observes that for the first time after drawing randomly the first box, whenever he or she observes for the first time that this box, this one box, okay, this one box is already emptied, maybe in previously in the maybe 14th trial, maybe 13th trial, maybe 12th trial, it doesn't matter. But at the 16th trial, he first observes first time that after drawing randomly the first box, he observed that the first box has been already empty. Okay, and we are talking about 16th trial, and it says that what is the probability that the remaining box will have I number of sticks. The second box will have I number of sticks. So over here I is equal to 5. Now is this much clear to you? তোমাদের কাছে ব্যাপারটা ক্লিয়ার হলো? কারোর কোনো কোশ্চেন আছে? হ্যালো, is it clear to you everybody? I don't know how many of you are listening properly. And please don't write this kind of comments, because whenever I am busy with my presentation, I don't observe all these kind of comments. Anyway, so let's continue. Over here, I am talking about this trial number 16, and in the 16th trial, we are observing that for the first time, one box is found to be empty for the first time, and remaining there are I number of sticks in the second box. So what would be the this number 16? This number 16 would actually be the fact that that should be n plus I plus one number of trials should be there. Okay, not I, rather I should say in this way. Over here I is in the middle of this, rather I should write it in this way. Out of this twice n number of trial, let's firstly deduce this already 5 already I number of sticks are there, so minus I, okay, twice n minus I plus 1 number of trial is this 16, means 16 designate that altogether we have twice n number of trials, out of which in the first twice n minus I number of trial we have chosen n number of first trials, n number of times we have chosen the first box, and remaining twice n minus I number of times we have chosen the second box. I am repeating this once again, that out of this twice n minus I number of trials, this 15 is actually twice n minus I. এটাকে একটু ছোট করে দিই। This 15 is equal to twice n minus I. Okay, so out of these previous 15 trials we have chosen this first box n number of times and consumed all these n number of success previously. Okay, and then afterwards along with that we have chosen n minus I number of times the second box. Therefore, if you count over here, you will find that over here altogether n number of success S are there, and how many failures are there? Altogether n minus I number of failures are there in this total twice n minus I number of trials. That means this twice n minus I can be written as n plus n minus I. This first n refers to the number of success, and this twice n minus I refers to the number of failure in this previous twice n minus I number of trials. And in the last trial, we definitely have chosen this first box because we observed that first box is empty, and that observation is done for the first time. Therefore, we can say that we can consider we don't need to progress further after 16th trial. We don't need to progress up to 17th or 18th or 19th or 20th trial. Okay, this is the first time whenever we encounter that the first box is empty. And therefore we can say that altogether we have or we need twice n minus I plus 1 trials, out of which first twice n minus I number of trials, out of which first twice n minus I number of trials will have n success and n minus I failures, along with success in last trial, or we can say success in this twice n minus 1th trial. Okay, so this is the case. So this is actually the first over here up to this much. This is you can consider it as an experiment in which we have altogether twice n minus I number of trials are there, out of which n number of successes there. So we can apply the Bernoulli's theorem, and along with this this experiment we have one more trial in which we are definite about our success. So probability of success would come. Along with that, we need to compute the probability of n number of success in this first twice n minus I number of trials, and that is actually we know that through binomial law, if we consider the binomial law, we know that this number of the probability of I success in n trials, that is actually the formula is q to the power of I q to the power of n minus I. Now over here in place of n we have twice n minus I, and in place of I we have n number of success. Okay, so what we need to do, in place of n we have to put twice n minus I, and in place of I we have to put n. So that would be the probability for n number of success out of twice n minus I number of trials, and this is for the first twice n minus I number of trials. Along with that, in the last trial we are confirmed about the success, and therefore by the definition of compound experiment, this probability has to be multiplied by the probability of success, and therefore it is the probability of success is, that would be actually is equal to P. Probability of success is equal to P, and as per our construction this P is equal to half. So we can say that this value would actually be is equal to এখানে p to the power of this p and this p to the power of n, these two put together make p to the power of n plus 1, and therefore this would be is equal to twice n minus I cn half to the power of n, half to the power of n, and again this half q is equal to half over here, therefore half to the power of twice n minus I minus n. So ultimately this value is equal to half to the power of this n and this n will get cancelled. So ultimately we will have twice n minus I plus 1. So twice n minus I plus 1. So this is the probability. So this is the probability of the fact that whenever the mathematician finds the uh, first box empty for the first time, we will have I number of matches left in the second box. Now, is it clear? ব্যাপারটা সবার কাছে পরিষ্কার? কারো কোনো কোশ্চেন আছে? Do you have any question? No question. So in that case, let's move to the next problem regarding this Banach matchbox, related to this Banach matchbox. Probably it was page number 79, something like this. After this, yes, in this example. Next we discuss about this case. Over here it says that in Banach matchbox problem, find the probability that when the first box is just emptied, that is the last match the last match or the last match stick is drawn from the first box, the second box contains exactly I matches. That means over here we are talking about the trial number 14. Okay, in the trial number 14, look at the question once again. When the first box is just emptied, that means in trial number 14, after using a stick out of this first box, it is emptied for the first time, and subsequently whenever we will choose the first box, obviously we will find an empty box. Okay, so over here the question is about trial number 14, not about trial number 16. Previously the question was about trial number of 16. Okay, that was actually twice n minus I plus 1 number of trial. But over here we are talking about trial number 14. Now what is 14? Over here this was twice n minus I, so this should be is equal to twice n minus I minus 1. Okay, forget about it. So we are talking about this trial number 14, and out of this twice n minus I minus 1 number of trials, it is observed that we are choosing the success in the last trial. So forget about all these results. At least we can say that out of this twice n minus I minus 1 number of trials, yes, we may have this number of trials because we may have failure over here, we may have success over here. So suppose if we have failure over here, we may have success at most in this position, so that in trial number 16 we get or we find an empty box. So we can say that in this trial number 15, that is actually this twice n minus I, sorry, twice n minus I, not this one. This is twice n minus I plus 1, and this is actually twice n minus I. So over here, in twice n minus I number of trials, we will get certain decisive conclusion. Okay, so you don't need this one. You don't need this trial number 16. We can talk about trial number 15, or we can talk about trial number 14. We can talk about trial number 15. In which trial the totally the match box would be empty. Okay, so it is clear that in the last trial, in trial number 15, we will be able to make a decision. And what is the decision? That the for the first time, the for this first box would become empty. Okay, and in that case, we can say in this twice, forget about this one, I am deleting this column. Okay, and we can say that we have twice n minus I number of trials. So in place of twice n plus minus I plus 1, we have twice n minus I number of trials, and out of which the first twice n minus I minus 1 trials will have how many success? We will have, if you count over here, how many such success are there? If you count, you will find that we have 9 success. 9 means n minus 1 number of success, and 1 success must be there in the last trial. Okay, therefore we will have n minus 1 number of success, and of course remaining how many failures? Remaining, if you count, remaining n minus I number of failures would be there. Okay, so n minus 1 plus n minus I becomes is equal to twice n minus I minus 1, and along with that one success in twice n minus ith trial. Therefore, the problem is very similar to the previous one, and in the previous trial, what we had twice n minus I number of trials. Instead of that, we right now have twice n minus I minus 1 number of trials. And out of this twice n minus I minus 1 number of trials, we have n minus 1 number of success. Previously, we had altogether n number of success. So what we need to do, we can say that out of over here, we have to write twice n minus I minus 1, and this is n minus 1 number of success, and then over here p to the power of n minus 1 would come, and twice n minus I minus 1 minus altogether n minus 1 number of success, and along that we have a success in the last trial. So the probability of success is equal to P, and therefore finally we shall have this type of result, this one. Then p to the power of কত হবে? P to the power of n would be there, and over here n and n would get cancelled. This I and I would get cancelled, so we will have n minus I. So we will simply have n minus I. Okay, and therefore this value should be over here this up to the power of n should be there, and over here n minus I would be there. So altogether this value should be is equal to this kind of result, and half to the power of twice n minus I would be there. So this is the final result uh, in sorry, in this kind of problem. So mainly these two problems have been selected in exam in different times. So hopefully this much would be sufficient for you. And similar other problems are there regarding Bernoulli trials, and this kind of summation kind of results are there. Okay, and that's all from this chapter. You can go through this kind of problems. I would suggest you to maximum go through up to this problem number 29, because the rest is about other kind of problem about Markov chain, although it is mentioned in your syllabus, but I would discuss all these results regarding Markov chain at the end of the entire syllabus. Okay, thus this one or two such special problems are to be discussed. Hmm. So from my end, this is all about this chapter number 2, and in the subsequent lectures hopefully I would be able to start the next chapter. Now if you have any other problem, you can contact me, and please go through this kind of problem number 5, 6, 7, 8, etc. These are very easy kind of problem, and I will post some problems. Probably I posted a few problems in your Google Classroom in this under this classwork tab over here in this chapter number 2. Over here few solved problems are there, so you will find many such problems in this part as well. So you please go through these problems, and if you have any further question, you can ask me in our subsequent class. Anyway, in that case, I would say thank you for giving or paying attention in this class.